In this particular routing, uh, basically the path has to select to transfer the data from source to destination. So the selection of path may depend on what we said here, the category of network and the characteristics of that particular channel and the performance matrices. So based on this, the communication path has to select. So basically, when we deploy the various sensor nodes, or when we deploy the various types of sensor nodes, so in that case, they can communicate directly when they are in the same communication range. If they are in the same communication range of each other, there is no need of any interference or there is no need of any mediator to transmit the information from source to destination. But the thing is, when the source and destination are outside the range of their communication range, then only the problem may happen uh, to use the multi-hop communication. So in that case, single hop communication is not possible as the two sensor nodes are outside the communication range. So in this case, these nodes has to depend on other intermediary nodes to transfer the information from one location to another location. So if you consider this particular image, let us assume that there are various sensors are deployed to measure the humidity of that particular a region, one particular region. So all these sensors will sense regularly to measure the temperature or the humidity in that particular region. So, so these humidity has to be sensed by these sensor nodes, and when it is sensing, then let us assume that as we can see here this is a sync node and there are the various sensor nodes, and let us assume this is our destination node. So when I am transmitting the information from sync node to destination node, it is not possible to directly transmission. So by using these intermediate nodes, we need to transfer. So whatever the data sensed by this particular sync node, it has to transfer to the destination node, so that it has to send by using various other sensor nodes which are acting as intermediate nodes are the routers. So the routing issue is the which path is going to be used to transfer the sensed data. So in this case, there is a one possibility we can see here the arrow marks with black color line is the path chosen to transmit the data. This is one possibility, but there are some other possibilities also. It may transfer the information from this sensor node to this sensor node, and this to this like this. Some other path the data has to be transferred to the destination. There is other possibility also. So, like this, there are different possibilities of sensing that particular sensitive information, sensing that particular information, and that sensitive information is going to be transmit the to the destination by using these various kinds of the paths. So, how we are going to send the information, and what should be the path, what should be the route, and what routing protocol has to be used to take care of this particular transmission. So these are the various for this to perform these tasks, we need to have a routing protocol. So basically, when we try to resolve the what should be the route and when that what should be the route to transfer the information which is sensed by the various sensor nodes. So this particular source node is going to send that particular destination or that sync node or the destination node by using the multi-hop communication. So here, basically, the routing protocols are categorized in two ways. Basically, the routing protocols are categorized in two ways. One is based on the architecture of the network, based on the architecture of the network, and the second one is based on the protocol operation. So these are the two basic categories we are going to discuss in this class. So let us have no need to elaborate all these things. So let us go for the protocol operation. So based on the protocol operation, the routing protocols are categorized into four categories, four ways. So one is called multipath routing, and the second one is called query based routing, and the third one is called negotiation, and the last one is called quality of service. So we have, let us assume that we have a source node, and let us assume that particular node is in transmission range itself. Let us assume that. So within that particular transmission range, we have different other nodes also. Like the destination node, we have some other nodes also within that particular transmission range. And from this source node, when we are trying to use multipath, that multipath routing to transmit the sensitive data to that particular destination or to that particular sync node. Let us assume that. Now, we have a source node and we have a destination, and these two nodes are in the same communication range, and we have some other nodes along with these two nodes in that particular range. Now these intermediate nodes will have to relay that particular packet, each of them whatever they received individually. So what we have is we have multiple options for sending the packet, as there are multiple nodes in that particular region. There are multiple options for sending the packet. One is uh, what let us go for, yeah, see. So when it is sending, we can see here the red color line. So this is one option for transmitting the information from source to destination, and there are like another route also it may use to transmit that. So, but likewise there are some other options, some other paths to transmit information from source to destination, and which can be adopted to that particular transmission of that particular packet. So now, when we are performing routing with or without the position information, we may perform the information or the packet with or without position information. So what the traditionally is, the when we have the basic sensor node, that particular node, uh, they can discover easily who are the neighbors of that particular node. That is a basic phenomena or the basic job done by each and every sensor node. When they are deploying, it is trying to discover who are the neighbors of that particular node. So once they deployed, they are trying to discover the neighbors of that particular node by sensing irregular intervals. So if the position information is available with the help of GPS or some other technology, then routing can be performed very efficiently, as that particular destination is node, the location of that particular destination node is known to the source node. So in this case also we need to have another class of routing protocols. So based on the category, we are going to have the category of other category of the routing protocols. So next we'll go for query based routing protocols. So in this case, whatever the protocols we need for wireless sensor networks, in this case, it will simply send the query to that particular region where we can call it as region of interest, where instead of sending simply broadcasting that particular route request, what it will do is it will select one particular region. In that region, it is trying to broadcast that particular information. That means if 10 nodes are there, instead of sending the information or instead of broadcasting the route request to all the remaining nine nodes, what it will do is it will choose one particular region, and for that region it is trying to broadcast the information. So whatever the region it is chosen to transmit the request is called region of interest, ROI we can call this as. So once it chooses an ROI, it is sending the broadcast request to that particular region. So if any node is interested in that particular region, it will reply to the requester. So that is called query based routing. So in this case, some network lifetime may be increased because we are not sending the information to all the nodes who are available in that particular network. And the third category is called negotiation based routing. So in this case, whatever the protocols we are using, that protocols we can call it as high level data descriptors, or it is using the concept of high level data descriptor to eliminate the data redundancy. When we are transmitting the information, there is a possibility of getting there is a possibility of receiving the same nodes from multiple sources. So to overcome the problem of redundancy, we may use this negotiation based routing protocols. So this uh, let us assume that there is a protocol which we are going to discuss just after some time, that is called spin protocol. So these protocol are the examples of these negotiation based routing protocols. So the main concept of this particular negotiation based protocol is whatever the duplicate information we have, which is transmitting from various sources to single node, that will be eliminated by using this negotiation based routing protocols. So the last category is called quality of service based. The name itself suggesting that quality of service. That is where the signal strength is more, where the quality of service parameters are satisfying the in that particular communication path. So it will consider the energy consumption and the quality of service. Let us assume, in particular, the network must meet some quality of service parameters, like what we discussed in the last lecture. The basic quality of service parameters of wireless network are like delay or bandwidth, likewise. So the distance or hope metric, like that, there are several matrices, quality of service matrices are. This is what we discussed in multi-hop communication. And when we go to the reactive networks, as we know, there are two categories of routing techniques are there. One is called reactive and second one is called proactive. So proactive means before initiating the transmission or before starting that communication process, it will have the knowledge of each and every event in that particular transmission. That is, it has to know, it will know the location of the source, it will know how many intermediate nodes are there in between source and destination, and it will know how much time is required to transmit that particular information. So this is called proactive. That means before initiating the transmission, it will prepare for everything, it will know everything, then it will start the transmission. But in the case of reactive routing, it doesn't do anything before the request comes. When any node is requesting means at that time only it will search for the processing of that particular query. That means when any request came at that time, it will start searching for the path, it will start searching for the intermediate nodes, or it will start searching for the how that particular route is going to be maintained. So in this case, the position is not required. The location of the destination is not required. Doesn't know anything. Simply, it will broadcast the request to know that where how many intermediate nodes are required to reach that particular destination. So especially we have ad hoc means temporary basis. Now it is going to be the major research area in future. The sensor nodes are, once it is deploying that particular stationary sensor nodes, we can call it as. So once it is deploying, the node may not move in it may not move within that particular network. But now the future research is in combining ad hoc network with sensor network, merging the features of ad hoc network with sensor network. That means mobile sensor network is the latest trend in research. It is going to be occupy the major share in the future research. Now, so in the case of the basic protocols, the standard protocols and the famous protocols which we have for this ad hoc as well as the mobile networks. So for these two categories, the basic protocols we have is AODV, ad hoc on demand distance vector, and dynamic source rating. These are the two protocols which will be used for ad hoc basis and in wireless network we can use. Whatever the protocols we are using now, there are so many categories of protocols are there. So whatever the protocols we are using now, all the protocols are coming from the concept of AODV or DSR, anyone. The basic concept is from these two protocols only, but they will improve some other parameter matrices. So by improving, they will release another protocol. But the basic are AODV as well as DSR. So when the data is going to be transmit, it has to establish the path or it has to fix how many intermediate nodes are there in between source and destination. So for that, it has to broadcast that particular message or simply it has to flooding of that particular request. So where this flooding was happened, we can call this that particular category of transmission is flooding based protocols. So the source node simply broadcasts the message to the neighbors. The neighbors, in turn, they are going to broadcast again, but they will maintain one duplicate copy with them. For future references, they will maintain a duplicate copy with them before rebroadcasting that particular message to their neighbors. And so then going to send it neighbors. Likewise, it will continue until that broadcasted message is received by the destination. So finally, what is going to be happen is because it is going to have the shortest path among in between source and destination. So whatever the path which is shortest, that path is going to be selected to for that particular transmission. So all the packets that are sending from source to destination are transmitting through this particular path only. So so let us have some short look about how this particular DSR and AODV protocols will work. I'm not explaining, just simply we can observe from the slides how the request is transmitting from source to destination and how the reply is coming back from destination to source and how the data is going to be transmitted. So in this case, what is the dynamic source routing is dynamic. Dynamic means what? It is a reactive protocol, not the proactive protocol. AODV is the proactive protocol, but DSR is the reactive protocol, which will not have the information prior to the transmission. When the request comes, it will initiate the process. So what it will do is, let us assume that S is the source here and D is the destination here. Now I want to transfer the information from source to destination. Here, where there are various paths to be established in between source and destination. Let us assume that one path may be S C G K D. This is one path, or S B H I G K D one path, S E F J D one path. There will be a possibility of getting multiple paths in between source and destination. So what it will do is when that particular transmission was initiated, simply it will broadcast the request. So here the control packet it is going to send. The control packet we can say that route request. So this control packet is going to be simply broadcasted to the neighbors. Who are the neighbors for S, B, C, E are the neighbors. So for these neighbors, this particular source is going to be broadcasting that particular request. Now, so in the first case, for all the neighbors, it will broadcast that particular information. Now, in the next step, what it has to do? The request is received by B, C, and E, And this particular, when this request is received by B, in the next step it has to rebroadcast that particular request. But the drawback of this DSR is when it is broadcasting, it will immediately send the return path for that particular source. See, so when B is broadcasting, in previous case you can observe the request packet is sending from S to B. Now the request packet is at B, C and E, which is transmitted by the source node called S. But in the second phase, what it will do is the B again it will broadcast. It doesn't check where that packet came. It doesn't check where that particular packet came. Simply the B node will broadcast again to its neighbors. Who are the neighbors here? Node A, node H and node S are the neighbors for this particular node B. Now, by this we can observe already the request is transmitted by S node itself, but again the same request is transmitted by node B, node C, node E. This is called redundancy. S is only initiating the transmission for establishing the route, but from their neighbors, S only receiving the same request to transmit to rebroadcasting again. And in the next case, the in from B it is broadcasting to A, H, and from C it is broadcasting to H, G, E, S again. So again in the next phase the G will broadcast to its neighbors again. In the next phase likewise F is also broadcasting, and the next J is broadcasting. At last the request is reached to destination. As we said initially, when any neighboring node is rebroadcasting that, it will maintain one copy and then rebroadcast. That's why when S is broadcasting, it will maintain one copy. From that, it will rebroadcast, again broadcast, rebroadcast like that. At last, at J, node J is having the copy called SEFJ. That means J came to know that from where the request came. It easily the node J can understand from source node S the packet is initiated. So now once it reaches to the destination, it has to reply with the route reply packet, again control packet it will send. So first the route request control packet will be initiated, then once it reaches to the destination it will send route reply packet control packet to the source. Now here as we can see there are multiple possibilities are there. For destination the request came from J as well as the request came from K itself, but it will choose any one. Which path is chosen by D? So the from where the route request is initiated first. And let us assume that the node J initiated the route request first, then K, then this particular path will be selected to get the reply. So node D is replying through this particular communication channel SEFJD. So in reverse path, it is sending the route reply. So once route reply was received by this particular source, now data is going to be transmitted through the same path. How many packets are there? All the packets are transmitted through this particular path. So once all the packets are transmitted, it is going to end that particular transmission. These are the advantages we have and disadvantages we have for DSR. So in the case of AODV, again the same process it is also using, but a small difference in transmission. So it is also simply broadcast that, but when it is broadcasting, it has to establish the reverse path immediately. Instead of broadcasting to reduce the redundancy, what we are going to do is it will establish a reverse path to the source. So initially the S is broadcasting the message to BCE and BCEs are establishing the reverse path to the source. Then in the second step, B is rebroadcasting the message to A and H, and C is rebroadcasting the message to this HG. So where the reverse path is there, it no need to send the request again. Likewise, it will continue till it reaches to the destination. So once it reaches to the destination, it will establish the reverse path. As we can see, the dotted line, it is sending the reply. So once the reply was reached to the source, it will establish the path, and during that path, that packet will be transmitted. So these are the two basic protocols initiated for the ad hoc as well as wireless networks. So next we'll go for data aggregation. See, the let us assume this aggregation was happened when, especially in fiber optical networks. Let us assume that there is one communication channel. So with that communication channel, we are going to send the information. Let us assume that. So the capacity, let us assume, take one example called RJ45 connector, the Cat5 cable. So that cable is having the capacity to transmit up to 100 MB per second. Let us assume from my node, from my system, I am sending only 50 MB of data. But the capacity of that particular cable is communication channel is 100 MB. So instead of wasting half of the bandwidth, what the communication channel will do is it will merge or it will multiplex the multiple data so that up to 100 MB it will make the data by combining multiple pieces of information. So once it will merge the data, it will send a single packet, 100 MB of data in single packet. Once it reaches to the destination, again it will divide. Likewise, so data aggregation in the sense, when the data is transmitting from one location to another location. So in that case, there is a possibility of combining multiple pieces of data into one single piece to transmit. So instead of sending all these individual pieces of data that are received by one particular node from all its neighbors, so what it can do is that particular node can aggregate, or that particular node can combine these multiple pieces of data which are collected from their neighbors into one single piece of data, and then it will be summarized. It will be the summarized data will be transmitted to intended destination where it has to reach. It will, through that path, it will transmit that. There are advantages like in combining these multiple pieces of data into one single piece called overlapping. We may overcome the problem of overlapping, and we may save the energy. Instead of sending multiple transmissions, we can perform all these multiple transmissions within a single transmission based on the capacity of the communication channel. So we can also overcome the problem of implosion. So implosion means we may overcome the problem of sending the duplicate message or receiving the duplicate message by one particular node. So when we aggregate that particular data, there is a possibility of there is a possibility of reducing number of packets in transmission. So there are different approaches for combining the data again, where there are various aggregation approaches are there, aggregation methodologies are there. So based on the type of data, some data it is possible to aggregate, but for some data it is not possible to aggregate. So let us assume one example. From that image we can see right side image, there are various nodes, and let us assume that these nodes are used to send the temperature of that particular region. Let us assume that, or humidity of that particular region. So in this case, what it will do is simply it will collect the information. Let us assume the node 4. So for this node 4, it is gathering the information from 6 node, node 3 and node 8. So these are the three nodes are going to be transmit the humidity information to the node 4. So what it will do is, let us assume that for our understanding, node 3 is sensing the data 3. Let us assume that humidity level of that particular region is 3. Node 6 is sensing the data 6 as the humidity level is 6 at that particular region. Node 8 is sensing 8 as the humidity level is 8 at that particular region. So what it will do, what the job, what sort of aggregation will do are done by this particular node 4 is, what it will do, simply instead of sending the raw data which is transmitted by these three nodes, node 3, node 6, node 8, what it will do, it will simply make an average of all these values and send to next node called 4. Here we can simply observe that, let us assume node 3, node 8, node 6 and node 4. If you make the average of all these values, 3 plus 8 plus 6 plus 4, how much? 10, 18, 21, 21 by 4. So we may get 4 5s are 20, 4 quarters 1. So 5.25 we may get. So instead of sending 5 transmissions, instead of sending 4 transmissions, it is sending only 1 transmission by taking the average. Likewise, here at the 4 node, we have an average called 4.92, which is transmitted by node 3, node 4 and node 5. And if these are, if when it is coming to node 2, again it is what node 2 will do, whatever the data transmitted by node 4, that is 4.92, and whatever the humidity level at node 2 is 3.46, it will make an average called, by making average it is transmitting 3.46 to next node. At the node 4, the average is 4.92. At node 2, the temperature level is 2. Let us assume that 4.92 plus 2, 6.92. 6.92 by 2, average is 2. So 3.46 here. 3.46 is transmitted to the sink node. Likewise, if this kind of data we have, we can easily transmit by aggregating that particular packet, multiple packets into one single packet. But there are some data where it is not possible for us to aggregate. Let us assume that if we have, if we consider one screen, our screen, so this screen is the aggregation of pixels, combination of pixels. But when you are sending this particular pixel information from one location to another location, it is not possible to take an average, because based on the pixel location only we are going to get the brightness, or we are going to get one particular image. So in this case, if we take average of these particular different pixels, the which are received from this particular neighbor, so it may, the actual data may differ, because the location of pixels may change at the destination. So it is not possible to combine, or it is not possible to multiplex this particular pixel information in the form of data aggregation. So what I am trying to tell is, based on the data we may aggregate, or we may, without aggregation also it is not, it is possible to send the information from source to destination. Now, so once the aggregation was done, there are some aggregative functions called duplicate, sensitive, exemplary, or summary, or monomotic, like that. All these are is to reduce the possibility of redundancy. So once this data was aggregated, we need to transfer the data. That is called dissemination. So dissemination in the sense sending the information or transmitting the information from one place to another place. Either that may be source to destination, or the neighboring node to sink, or one neighbor node to another neighbor node, like that. So this is a process. Data dissemination is a process where we can simply, we can call this as a flooding. Dissemination means transmitting. It has to flood that particular information from one location to another location. Here, three things we need to consider here. One is called source, who generate the data, and other is called sink, or the destination, who receive the data, and there is another thing called event, where the information is going to be reported. The information is going to be repeated is called event, and the node who interested in that particular event. When any event is occur, if any node is sensing, means that node is interested to participate in that particular event. So that node is called sync node. So usually this data dissemination will be performed in two steps. One is called interest propagation, and the second one is called data dissemination. So before transmitting the data, it has to know whether that particular node is interested or not. Whether that particular node is interested in to participate or not. For that, interest propagation is required. And once that particular node receives interest from the neighboring node, it has to disseminate that particular data. So, but there are limitations in data dissemination also. So, in data dissemination, we have two categories of disseminations are there, as we said now. One is called flooding and the second one is called gossiping. So flooding is nothing but simply it will flood. It will broadcast all the nodes who are available in that particular region, who are reachable to that particular source node. It will simply broadcast that particular request. So up to what level these nodes are going to be broadcasted? That means there is a hop count, that is number of hops in between source and destination. We may fix how many number of nodes can be chosen in between source and destination during that particular transmission. So if that hop count is reached to maximum level, it will not disseminate any data. That means if I am fixing that hop count is 4, that particular node is going to be broadcasted to the neighbors hop count. Again, these rebroadcasting to their neighbors hop count 1, then broadcasting 2, then broadcasting 3, then broadcasting 4. So once hop count is reaches to 4, it will not rebroadcast that particular request or that particular information. So it is very easy as well as simple to implement, but as we said now previously, we may face the problem of implosion, redundancy, or we may face the problem of overlapping, or we may face the problem of resource blindness. Without, that means resource blindness in the sense, without checking the availability of that particular resources, it will simply order. Without knowing the availability of that particular resources, it will start the initiation or it will start the process. So gossiping in the sense, we can say that simply some kind of control was there. It is also similar to flooding, but there is some kind of control uh, for that particular flooding. So we can simply call this is a modified version of flooding or controlled version of flooding. So in flooding, what it will do? Simply it will flood the information to all the neighbors. But in the gossiping, instead of flooding to all the neighbors, it will broadcast to the some particular node which is randomly chosen by that particular neighboring node. So instead of sending to all the nodes, it will choose one node or some set of nodes, and for that nodes, this information will be broadcasted. Instead of sending to all the neighbors, only limited neighbors are going to receive that particular request in the form of gossiping. So again, for these kind of flooding based approaches we have, there are some limitations are there. As we said now, overlapping, resource blinding, and implosion problems are there. So they will simply keep on forwarding the data to the neighbors without taking into the consideration that whether the nodes which are going to be transmit have the sufficient resources or not, sufficient resources available with them or not. So this kind of solutions are not suggestible for use in sensor networks. So to overcome these problems, we need to have some better algorithms or some better protocols to overcome these problems. So as we said, this is second category of the protocol is called network structure category. So one is routing protocol category, which we discussed in the first slide, and the second one is called network structure category. So in this, we are going to have three categories of protocols are there: flat based or data centric routing protocols, hierarchical based or clustering based routing protocols, and the third one is called location based protocols. So when we have a discussion about one by one, let us see. So in data centric protocol or the flat based protocol, what we have. So in this protocol, usually when we talk about the sensor networks, we need to discuss about the sensing of data or the sending of data or the handling of data. Likewise. So these are the things we need to discuss when we are talking about the sensor network especially. So all these about data exchange between the different nodes. Always we are saying that sending the data is receiving the data are intermediate nodes. So this communication is going to handle all about exchanging the information between the nodes. So I'll explain that simplicity. That means when we talk about the simplicity means there is no specific approach is required here. In the case of flooding, there is no specific approach is required. Simply, whatever the information it is trying to send, it will simply broadcast. It will not check whether it is required or not, whether that particular intermediate node is needed or not in this communication. Even though within a short duration, within a short range, if multiple nodes are there, it will send to all the nodes. So there is no complexity in establishing the flooding. In the case of dissemination, what we are saying is it is choosing some nodes. So to select that particular node, we need to have some methodology, some approaches we need. So we need to choose for best approach, or based on that approach, we are going to choose one particular node to transmit. But in the case of flooding, there is no approach is required. Simply, it will check the neighbor. The basic phenomena of the sensor node is to sense the neighboring node once it was deployed. So it will sense means it is having the information of the neighbor. How many neighbors are there? For all the neighbors, it will send the information. That's why the advantage is we are calling this as it is easy to implement. So when we come back to this data centric routing or flat based routing, so these data centric routing protocols, we can say that they are associated with the data and use them to make the routing decisions. So whatever the data, based on the data, it will decide. And actually, when we are utilizing the specific address like IP address of that particular node, it is easy to transmit the data like gossiping. So instead of sending the same data to multiple users and number of nodes, it will choose that. So how we are going to choose? Let us assume that that particular node is going to be identified with specific address called IP address. So with that IP address, it is going to send that information. So, especially for this data centric routing, these flat based routing protocols need some kind of identification mechanism or some kind of addressing mechanism, which means so each and every node is going to have is having a specific address associated with them, like an IP address, and the once the IP was enabled, uh, so that we can use this address to identify that particular node and how where the data is going to be sent from the specific point onwards. From that particular point onwards, we can easily identify where this data is going to be transmitted. So who is the next neighbor to transfer to reach that particular destination, because we know the location of the destination, so we know the identity of the destination. So based on that, we can simply reroute the packet so that within limited number of hops, the data is going to reach it to the destination. So in these particular data centric routing protocols, uh, we are saying that some sort of identity is required, but it is not mandatory to have the IP address. Any identity we can make, like some naming mechanism, and they will exploit the use of that particular naming mechanism that are associated with that particular data, and we will use them for that based on the naming mechanism, based on the data we have, we are going to choose, we are going to decide which path is suitable for that particular transmission. So there are different examples we will discuss now for these data centric routing protocols. As we discussed just now, flooding and gossiping, these two are the examples for flat based, and we have another protocol called spin, as we discussed in the early in the class. So that also we are going to discuss, and there is direct diffusion. These are the protocols we are going to discuss under this flat based. So let us see. So these are the examples we have: flooding and gossiping, spin protocol, sensor protocol for information via navigation, and another protocol is called direct diffusion. These are the examples of data centric routing or flat based routing. So let us go for one by one. So in the case of spin protocol, the sensor protocol for information through navigation. So we have a set of different nodes, as we can see from this particular slide. We have a different nodes A, B, C, D up to H. So in this particular example, let us assume A is the source node. Okay, A is the source node, and so as the A is the source node, definitely that means A is the initiator. So when A is the initiator, it should have some data to transfer. So directly we can say that the owner of that particular data is A. The source node is A. So instead of sending the data to its neighbor B, instead of sending the information to its neighbor B, as it is having the nearest among the neighbors C, B, E, F, B is the nearest one, so it has to send the advertisement to that particular node B. So I'm repeating again, instead of sending the data directly, it will send an advertisement to check whether that particular neighbor is interested to receive my data or not, is interested to retransmit that my data or not. So first it will advertise saying that I have some data, just like I have some kind of metadata. So node A will advertise to all the neighbors, as B is also neighbor. So first it will receive as it is the nearer to the source node A. So if node B is interested based on the communication established by node A, then node B will send the request for the data. If node B is interested, It will send, it will give some response. Okay, I am ready to receive a data, send the data. So in the next step, in the step 2, what we can see in the figure, B is sending the request to transmit the packet for the node A. That means now node B is ready to receive the packet. So it is sending the request to A to start the transmission, start the data transmission. And in the step 3, we can observe the node A is sending the data. Then, now what the node A did, now node B has to do the same. Now the data is with node B. What it has to do, instead of sending the data, it will simply advertise, I have some data if anybody is interested to receive or not. If suppose among the nodes C, D, E, in the step 5 we can see that nodes E is requesting, node E is also requesting for the data. So two nodes are requesting. So what B has to do? It will transfer the data to both the nodes. So this is the basic ideology of the spin protocol, but this is the basic protocol. So later they improved this protocol based on the category of data, based on the structure of the network. We have various versions of this spin protocol. As we can see from this slide, there are, when we are having point to point communication, instead of using spin protocol, spin PP version is point to point protocol version is useful. And when we have want to save the energy, then spin EC version is used. When we are broadcasting without checking the identity of the node, without checking the location of the node, then spin BC is useful. And when we have a lossy channel, there is a possibility of getting lossy, then we may have this spin RL. So there are different, like this, there are different other protocols which are proposed by various researchers, which belongs to this particular class of spin protocols. The concept is same, but whatever the protocols are not specified here, other version of spin protocol, the concept is same, but there are some addition, adding some facilities are added to this particular spin protocol. So if we observe this particular right side image, when the node A is basically sending an advertisement to all the neighbors called B and other two nodes which are in black color. So node B in this particular case, it has to receive the information, or it has to receive the advertisement which is transmitted by the node A. So this node B, it has to send a request to node A for getting the data from getting the data back from node A. So once the node B receives the data, again it has to rebroadcast that information, as we discussed in the same case. It has to rebroadcast the request. Once the request is received by that particular node, it has to send the data. But in this case, based on the requirement, if we have a point to point communication, this pin PP version of this protocol is going to be used. And if you want to save the energy, then spin EC protocol is going to be used. So especially this particular spin AC is very popular protocol, as we are talking about saving the energy or storing the energy when you are transmitting the information. So this energy conserving spin protocol, it adds what it just like a point to point protocol only, but it will add the feature called energy conservation. It will add the feature called energy conservation to the basic spin protocol. So this spin PP protocol, which is basically we can say that when we need a low energy, when we need a less energy, in that case this spin point to point protocol can be used. So in this particular protocol, there is a threshold for energy, there is a limitation for that particular energy. When that energy reaches to that particular threshold, it will not perform any other operation except control packets are going to be transmitted. It will not transfer any data packet once that particular energy will be reached to that threshold value. So that's why we are using this easy version of the spin protocol. So which is useful in conserving the energy. So which tries to minimize the energy consumption of that particular node. So when multiple nodes are participating in the routing, so this energy conservation protocol is useful. So as we said, the another category of protocol in flat based is called direct diffusion. So in this, three versions are there. So it is also just like a spin protocol, and this the basic idea of this direct diffusion is we need to have the we can call it as data centricity, data centric, as it is a data centric protocol. It has to have some data to transmit. So this transmission was done in three ways. What is called two phase pull, one phase pull, and push diffusion. So a sensor node will transfer the data directly to the base station if that particular base station is in the same communication range. So if suppose the problem is when this particular node is outside the range of the base station, or when the node is far away from the base station, it has to consume a lot of energy. It has to, the cost of that particular energy becomes more. So, when it is going to route the packet, according to direct diffusion, there are various steps to be followed. So in the first step, it has to propagate the interest, or what we discussed in the data dissemination. Interest propagation is the first step. It will check with the neighbors whether that particular neighbors are ready to receive the information or not. So then, if any neighbor is ready to receive, then it has to transfer the particular message. It has to forward that particular message. In the third step, that what we can see from this image is called, it has to form the gradients. So first it has to propagate the interest. If any node is receiving or responding for that particular request, it has to transfer the data. So once the data is transmitted, it has to check for the gradients. And the fourth step, once the gradient is confirmed, then it will use that particular path to transfer that particular information. So these are the four main steps which are used by this direct diffusion protocol. So if you observe this image, this example, we have a sync node which is represented in yellow color, and we have a node which the sync node which we okay, let us assume that we have a sync node, and this particular sync node usually broadcast that particular request message or interest message to all the nodes who are in that particular region. So the sensor, the whatever the sensor nodes will receive the request message, they has to create the links. We can say that the nodes which are creating the links are called gradients. So uh, These what the gradients will do is, once any message is passed, once any request is passed from the sync node, immediately the gradient nodes are attempting to create the reverse path along with the forward path. It will create the reverse path. So like this, the this process has to be continued until we reach to the destination. But this particular direct diffusion is very much useful when we have limited number of nodes. So we cannot use direct diffusion approach when we have a larger number of nodes are deployed. So if the event has occurred in any around that any particular node, this node is going to report along this particular path. So along the path, the node which will sense that particular event, that also report to the report has to be transmitted through the same path. And finally, whatever the different paths that are obtained or that are adopted, so the least hope count path will be chosen for data transmission. So it is this particular approach, just like a spin protocol approach, but only the thing is, it will be the path will be chosen based on the hope count. So where the hope count is less, that particular path will be chosen. So as we can see here, the sync node is broadcasting to all the neighbors. Then this particular node is also broadcasting to their neighbors. So once that particular broadcasting was occurred, in the second image we can see the dotted lines. So these dotted lines are the gradients, that it is establishing the reverse path. So once the reverse path is established, let us assume that there is an event occurred at this particular node. So this event is also be transmitted to the sync node. So once it reaches back to the sync node, it will check which path is having less number of hope count. So here, if let us assume this path, the red colored path will be chosen for the transmission, as it is having only one hope count. The hope count is 1 for this particular path, so that it will be chosen for that particular transmission. So in two-phase pull, again the process is same. I'm not explaining all the thing again. So first it has to propagate the interest, then the sync transmit that request to all the neighbors until it comes to the node which is a source node. So the source node has to respond. It will respond. So what we have, the yellow color nodes will act as a source node, because this particular node is going to sense that object, and then what it will do is, it will respond back along the various paths, different paths it is having, various options it is having. So this is the gradient setup phase. In that gradient setup phase, from where the response came, it will establish the reverse path. So once the gradients are formed, so the least hope count will be chosen for this particular communication. Either from the source node to this node, this node to this node, or this node, or this path. These two possibilities are having the hope count 1. So this particular path will be chosen. Likewise, in the same case, in one way also the same one. The one phase full diffusion is also the same. But in this one phase pull, it sends the data only on the preferred gradient. Instead of sending to all the gradients, it is sending the preferred gradients only. So the how to choose that preferred gradient? among the other nodes, how it is going to choose one particular node. So this particular gradient is determined by the neighbor who was the first to sending the interest. Who is sending the interest first, that node will be chosen as a gradient node. So thus, this one phase pull does not require any reinforcement of messages. As in the two phase pull, there is a reinforcement of path and messages, but in this case, it is not required. So, in the third phase called third category of direct diffusion called push based diffusion. So, this is almost, it is also like same thing, but when we have the applications like where the nodes are generating the data continuously in regular intervals, the nodes are generating the data. So in that case, this particular according to this push based diffusion, there are many nodes will come forward to act as a sync nodes. So when many nodes are acting as a sync node, all the sync nodes are going to receive the information, the same similar kind of information from various sources. So again, it is becoming the redundancy of that particular network. So when we comes to design consideration, we can observe from this slide interest propagation, data aggregation, and reinforcement. So these are the design choices for this direct diffusion. These are the pros and cons. So there are different advantages as well as different advantage disadvantages for this direct diffusion. As it is a data centric routing protocol where we do not need to have any kind of IP addressing that has so that the node can easily adopt it to that routing path, but there are some uh, disadvantages. At the same time, this particular node in this direct diffusion is having the capability of combining the message and caching the messages. So one of the disadvantages is called, as we see, it is a on demand, and so this approach is inappropriate for the applications that require continuous data delivery, like the environmental monitoring. So in such cases, this direct diffusion approach is not suggestible. And one more disadvantage we have is uh, we can say that some naming approach called attribute based naming scheme, and it is completely the application dependent. So for each application, it should be defined what that application is going to specify. And also, there is a over processing overhead or extra processing overhead at different sensor nodes are required by adopting this particular approach. So we have another kind called Rumer routing. So the basically Rumer routing in the sense it is just like gossiping. Instead of sending the packets to every node, it will select some random nodes, and after after selecting that random nodes, it will transfer that particular packet to that random node. But the thing is, the difference between direct diffusion and this Romer routing is it will have some threshold value in number of hops. There is no energy constraint here. It will not consider whether the sufficient energy is there or not, but it will have some threshold value for hope count. That means after visiting some number of hopes, the it will die. It will not perform any other operation after visiting k number of hopes. Let us assume in general, and there is no guarantee it is not providing any guarantee by the Rumer routing to which will all the nodes will receive that particular message or not. It will not give any guarantee. So each node is going to have is going to maintain one table called event table, like, and there is another protocol called MCFA protocol. Okay. So MCFA protocol. So in this minimum cost forwarding algorithm. So the name suggesting that it will forward the messages where the minimum cost will be conserved. So in this case, the direction of routing is always known because it has to check the minimum cost. So it will preserve the information before transmitting. It will collect the information from the neighboring and preserve with it. So the direction of routing is always known, and the direction towards the sink or the base station. So it will check how many neighbors are there, how many intermediate nodes are there. So the sensor node for this case, it is already having information. So these nodes are no need of having any identification information, or to maintain a routing table is also not required in this case. So instead of that, each node will maintain the least cost estimation to its neighbors and to base station. So instead of maintaining the routing table, it will maintaining the table, but in that it will maintain how much cost is required to reach the neighbor, how much cost is required to reach the base station. So when the node receives a message, it checks if it is on the least cost path between the source and the base station. If it is the case, it rebroadcasts the message to the neighbors. If it is not, it will not rebroadcast. So this process will be repeated until the node, the base station is going to receive this particular request. So simply, instead of maintaining the routing table, it is a proactive routing table, a routing protocol. So instead of maintaining the routing table, it will maintain how much cost is required to transfer the information to its neighbor. So let us assume 5 neighbors are there. So it will maintain the information with these 5 fields, so that it before transmitting itself, it know how much cost is required to transfer that information. So next protocol is called hierarchical based protocol, or the clustering based protocol called LEACH. I think it is not coming up. What happened? So in this, is it audible for you?
Yes, reasonable.
Okay. So we already seen that data centric routing protocols for sensor networks, and we have seen that localized routing protocols, which will basically work on the basis of location information. So specific location information like longitude or latitude. So there are that we'll discuss now, the location based. And the other kind of the other class of routing protocols is called cluster based routing protocols. So in this cluster based routing protocols, the first protocol we are going to discuss is LEACH. So low energy adaptive clustering hierarchy. It will consume less energy. It will easy to adopt the clustering hierarchy. So the objective of the LEACH is basically to improve the lifetime of that particular network and to reduce the consumption of energy by the different nodes, and the we can also have the aggregation of data concept to reduce the number of communication messages, to reduce the number of communication messages. So it is one of the clustering based routing technique or the hierarchical based routing technique. That means the different clusters are formed using different sensor nodes based on the various matrices like the signal strength which is received by one particular node. So for each and every cluster, one leader is going to be appointed. So that leader is called cluster head. So these local cluster heads route the information of that particular cluster to the sync node, towards the sync node, and these cluster heads are basically randomly changing over a period of time. So one particular node is not fixed to act as a cluster head, as we discussed in the previous lecture. So after some duration of time, the head is going to be changed. So these cluster heads and leads are assumed to maintain one hop connectivity to the base station. This is very important. So it has to maintain only one hop connectivity. So it will not transfer the information in larger networks. So where the one hop connectivity with the base station, the nodes which are maintaining one hop connectivity with the base station, that nodes are going to be retransmit that particular information. So as we can see here, this particular LEACH protocol is efficiently worked on the smaller networks only, and because of the clustering, we may face the problem of overhead. As we can see from this particular figure, we have different clusters are formed. Three clusters are formed here, and for each cluster there is a cluster head which is represented in red color. This particular cluster head is responsible for data aggregation to report that particular cluster members, and this aggregated data is finally sent to the sync node through one hop connectivity of that particular link. So you can see here each and every cluster head is directly connected to the base station. This cluster head is directly connected to the base station. Likewise, every cluster head is directly connected to the base station. So, the basic operations of LEACH are organized in two different ways. One is called setup phase, and the second one is called steady state phase. So, in the setup phase, what we are going to do is this particular setup phase is again which is going to be implemented in two phases. One is called forming the cluster, and the second one is called choosing one node as a cluster head. So once this setup phase was done, in steady state phase, it will these particular cluster heads are going to gather the information from its neighbors. Once the information is gathered from the neighboring nodes by the cluster head, it will the cluster the cluster head will aggregate that particular information so that the aggregated information will be transferred to the base station. So the advantage of this particular LEACH protocol is as it is a distributed protocol, so where there is no requirement of global knowledge of that particular entire network, and it increases the lifetime of that particular network. When we comes to disadvantages, it is a it uses single hop routing within the cluster. So, and it is not applicable to the networks in larger regions. When we are dealing with large networks, this protocol is not applicable. Dynamic clustering approach that is adopted by the LEACH, it invites the additional overhead in terms of advertisements, so which will consume a lot of energy and which is undesirable for the sensor network. So these are the limitations of this particular LEACH protocol. Like LEACH, there are some other protocols also: self-organizing protocol, virtual grid architecture, hierarchical power-aware routing. So when we comes to self-organizing protocol, which is also the clustering-based routing. So this particular SOP protocol used to build the architecture and to support heterogeneous sensors. So when we have heterogeneous sensors, this protocol is very much useful. So these sensors can be a mobile or a stationary. Both type of sensors are available in the market. So some sensors will propagate that, but will propagate that environment and forward the data to uh, the some set of nodes which are designated or which are intended to receive. And when it is receiving, when some nodes are chosen to receive the information, if they are in the same range, no problem. If they are not in the same range, it has to uh, transmit through intermediate nodes. So these intermediate nodes will act as a routers in this protocol. These router nodes are stationary and form the backbone communication for this particular transmission. So whatever the data collected, that has to forward through these routers, so that that data is going to reach to the base station. So each sensing node should be able to reach that particular router in order to be a part of the network. These sensing nodes are identifiable through the address of that particular router node. So when we comes to the next, the cluster based routing protocol, virtual grid architecture. So as we can observe from this image, there are various grids. Each and every grid, instead of forming cluster, here grids are formed uh, in square format. So each and every grid is going to have one cluster head, that is grid head, which is represented in black color, and remaining white color circles are called the various nodes. So in this, again, the data aggregation approach is used to maximize the network lifetime, because these nodes are stationary and it is having very low mobility in many applications of wireless sensor networks. To arrange the nodes in fixed topology, the GPS is not required, or GPS free approach is used to build the clusters for which are fixed in size, which are equal, which are adjacent and non-overlapping with symmetric shapes. So in square clusters, where these particular square clusters are used to obtain fixed virtual topology, virtual topology. So inside each zone, the node is optimally selected to act as a cluster head. So that's why these nodes are, we are saying that virtually, that's why we can say that virtual grid architecture. There is no actually grid, the grid is formed on virtual basis. So the last hierarchical clustering based algorithm is hierarchical power aware routing. So in this protocol, what it will do is it will divide the network into a group of sensors. It will divide the whole network into group of sensors. So each group of sensors in a geometric region or geometric proximity are clustered together as a zone, and each zone is treated as an entity here. Each zone is treated as an entity. To perform routing in each zone, to perform this particular routing in each zone, these are allowed to decide how it will route the message hierarchically across the other zones so that the battery lives of the nodes in that particular system will be improved. So these messages are routed along the path which has the minimum, uh, the remaining power called maximum minimum path. So it will check the node which is having the minimum power, that node will be opted for the transmission. So the third category is called location based routing. So in location based routing, the algorithm, the first protocol is called geographical adaptive fidelity. So based on the geographic region or based on the geographic location, it is going to be the data is going to be transmitted. So it is also consuming less amount of energy, and it is location aware routing algorithm designed primarily for actually it was, for mobile ad hoc networks, but it may also applicable for wireless sensor networks based on the situation. As these sensor nodes are sometimes there is a need to deploy the sensor nodes in dense geographical regions. So the network area is first divided into zones. The network area is divided into some number of zones, and this zone, after dividing the network into various zones, it will form one virtual grid. So inside each and every zone, these nodes are the nodes which are deployed in that particular zone are in collaborative manner with each other to perform various tasks. For example, the nodes will elect one sensor node to stay awake for a certain period of time and then go back to sleep. So this particular node is responsible for monitoring and reporting the data to that particular base station on behalf of all the nodes in that particular region. So definitely because of this geographical adaptive fidelity is going to save energy by switching off the nodes which are not necessary in that particular communication, so that even though some nodes are going into sleep mode, which will not affect the which will not affect the performance of other nodes in that particular network. The another algorithm is called span algorithm. So in this, some nodes are selected as the coordinates based on their positions. So these coordinators form a network that is which are used to forward the messages. Once a node becomes the coordinator, if two neighbors are coordinating with this particular coordinating node, and because of this some all the nodes are not using the energy, not using the much energy. So because of this particular design, the consumption of energy is going to be reduced. So in this, the network is formed based on two or three hope neighbors, based on two or three hope neighbors. So if you observe this particular image, there are some nodes, let us assume node 5 and node 3. If they want to communicate with each other, then there is no direct communication between node 5 and node 3. It has to pass through all these corresponding nodes to reach node 3. So what it will do is, if this particular connection was established, or if that particular topology was connected with node 3 and node 5, there is no need of transmitting through all these particular nodes. So another location based algorithm is called greedy position based localized routing. So in this, so in this, if you consider this particular example or the particular image, so the basic idea of this greedy position based localized routing is it will check the nearest neighbor. It will check the nearest neighbor. If suppose if we consider the destination which is outside the range of source node, if we have a source node here and we have a virtual range of this particular source node, but the destination is outside the source node range, when it is trying to communicate, these will check the nearest node. If suppose node S is there and here node C, node A is there, when source node is trying to communicate with the destination, it will check the nearest node. So among C and A is the nearest node, so it will choose A to transmit the information. In the same way, for D also, D the nearest nodes are E as well as B, so it will check the nearest node. Based on that, it will choose that. So we are as we are discussing about the localized protocols where the source node knows only the position of itself, it doesn't know the position of the other nodes, and the when it is sensing initially, when it start initiating the first time, it will collect the information from the neighbor. Then here in this case, the neighbors, it will collect the information from the neighbors called C and A, then it will store with S. Now the S knows the location of itself, the location of A and location of C. In the same way, C knows the location of S, location of A and location of E, like that. So the source node, because it knows the position of itself, the source node, and as well as the location of A, location of B and location of D, after some refreshments, it can decide which one has to be used in this particular transmission. So node, that is node A or the node B, to forward this particular message. It can also decide which one has to be used in this particular communication. So in this particular case, instead of sending to node A, we find that, let us assume that node B is nearest to the node D. It is having the closer proximity to node D when is compared to A. So the node B will be chosen to transmit the message to the source node. So from node B again, it will choose the nearest node A, C, E. Among these three, A is the nearest one. Then B is transmitting the information to A. From A to S. Like this, it will transmit. So they are the variants. We will discuss later. So what is the difference between the greedy algorithm and shortest path algorithm? As we can see from this image. So let us what the various variants. So if you look at this particular image, the localized as well as globalized protocol, this whatever the greedy variants we have A, B, C, E, F, these particular variants and the shortest path variant, if we compare, which is the optimized with the least number of hops. So in this particular image, S, E, D, S, E, C and D, so is the path with least number of hops. So this particular shortest path optimized algorithm, which can be adopted for routing between source and destination. So based on number of hops, if we count, see, S, A, B, C, D. How many hopes are there? This is the source. One, two, three hopes are there. In this case, 1 and 2. So there is a two hop connectivity for so that the shortest path will be chosen in this particular way. But in the case of greedy approach, what we said is it has to choose the nearest one. So the other possibility in that particular greedy approach is if you adopt that particular node A is the closest to D, let us assume that, which is intended destination node, that is D. So the node S will send the information to node A as it is closest to D, which is similarly, this approach can be followed in throughout the communication. By following the greedy approach, this path will be obtained for transmitting, for relaying the packet from source to destination. So when we talk about this particular shortest path algorithm, there is a possibility of getting overhead. So the message is to maintain the global information at each and every node, following who follows that particular mobility, and sleep active period could be an overhead that cannot be. We cannot ignore this sleep and wake up policy in shortest path case. So another routing approach in greedy is called directional routing, or you can simply say that compass routing. So this particular compass routing is uses least angle instead of maintaining distance or instead of maintaining signal strength. It will work on the basis of the angle with less angle. So based on the angle, it will decide which route is to be selected to transmit the information. Let us assume that here, if we consider the line SA, which makes less angle with SD when we comparing with remaining angles. This angle is very less when we comparing with remaining angle. So this particular node A will be chosen to transfer that particular information. So this compass routing determines which node has the closest direction, that is the smallest angle with the source and destination. Then this is the direction based routing. So in this particular direction based routing, we can say that which is not a loop free, there is a possibility of forming the loops in this particular routing technique. So if you observe this particular image, it has to choose the least angle. So from there it will forward again the least angle forward again there is a possibility of getting loops in directional routing. So let us go for two protocols which we have, which are worked on the location based protocol along with the what we discussed here. So this location based strategies, again you are going to have angle itself. So Dream LAR are the two protocols which are followed again the flooding based strategies. So the approach is to send to all the neighbors within that particular angular distance, whatever the distance we found in the particular image. In that particular angular image, it is going to form one cluster. So with a specific radius. So within that, the radial distance, it is going to uh, send the information to all the neighbors. So from this particular figure itself, we can observe clearly that angle made around angle made around the range of that particular destination. So let us assume this is a destination here, and we have some radius based on this angle. So within this particular radial angle, it is going to transmit. So all the nodes that will fall within that particular angular region are going to be flooded with that corresponding messages. So that is the source node S as the source node S is sending towards the information destination, sending the information towards the destination. The other approach is also quite similar, like in LAR. So we have a source node, we have a destination node. Around the destination node, it is fixing some location, and in that particular location, it is going to have send that particular information. So the source node will flood that particular packet to all the nodes in that particular rectangular region. So if it comes to the first protocol called tree, so as it is a location based protocol, each node is maintaining a position database that which will store the information about each and every other node which are in that particular part of that particular network. So it is possible to install the GPS system so that each node to know its geographical coordinates like longitude and latitude. So this, because of this GPS, we may call this particular protocol as a reliable protocol because each and every node knows its neighbors along with that location. So the advantage of exchanging the location information is that it will consume, definitely it will consume less bandwidth than the exchanging the complete information with the neighboring nodes. So as it is a position based algorithm which is specially designed for mobile sensor networks, so this, we can say that based on the forwarding directional approach that floods the data in a particular direction towards that particular sync node. So we have a drawback in this particular dream protocol. It maintains a routing table to store the information in that particular at each and every node in that particular network. Therefore, when we have a large network, the routing table is going to be, the size of the routing table is going to be increased. So each node, for each node, it becomes the overhead to maintain all node information in the form of routing table. So in the case of location based routing, in this we can see there is a request zone and there is an expected zone. So instead of simply broadcasting the request to all the nodes, what it will do is it will fix some location, and in that location, by assuming only, there is no guarantee here, the source node may assume that in this particular region the destination is going, we are going to have the destination. So that particular zone is called expected zone. So this is the request zone and this is the expected zone. That means instead of there is a whole network in large size, and in this particular network we are framing one rectangle. In this rectangle we are going to expect, we are going to assume the expected zone. So in this case, what is going to happen? This particular source node, we can see outside of the rectangle there are some other nodes. It will not send any request to the nodes which are outside this particular rectangle. Simply, it will send the request to all the nodes within this particular request zone. Then, once it is receiving the response from the various nodes, by seeing the response, it will frame one expected zone with the fixed radius. So, within this, with if this for this particular expected zone only, the data is going to be transmitted. So this is location aided routing. So we have some advantages as well as disadvantages. So likewise, there are some other protocols which are not related to the category what we discussed here, location based or that location based or hierarchical based or clustering based like that. These are not related to any other categories. There are some protocols which will deals with especially deals with mobility. As we said, these wireless sensor networks, there is a future scope in making the mobile sensor networks. So when mobile sensor networks are deployed, then these protocols are going to play very important role. So these protocols may be modified later, but these are going to have a very good impact in mobile sensor networks. So when we comes to this particular protocol, AWS drop and register. So for this particular stationary network, if mobility is introduced, then these because of this mobility, the connection establishment between the nodes are very important. So where we have a limited power consumption and where we have a limited processing rate, so the packets are exchanged to relay data from network whenever it is necessary. It has to exchange the information even though uh, there is a rule called limited power consumption. So because of this mobility, that particular node may not complete that particular task. So it became overhead for for in that particular transmission, because during the transmission also there is a possibility of mobility. So it will, when during the transmission, if node is shifting from one location to another location, if it is outside the range, then it may not transmit, so the transaction may be terminated in the model itself. So this particular in such cases, this particular protocol will provide the continuous services in for the mobile nodes, where we have stationary as well as the mobile networks. So another protocol is called leap. What it will do is, it is also just like a cluster based, but the node in each and every cluster is going to have one identification number. So for that, it is going to maintain various keys. So one side it is advantage, but other side maintaining these number of keys are very difficult for each and every node, that particular cluster head. So it will maintain the individual key, it will maintain the group key, it will maintain the cluster key, it will maintain pairwise share key. So the individual key is known to that particular node along with the base station. The group key is common for all the nodes who are available in that particular cluster. The cluster key, which has to be shared between node as well as the neighbors who are in the cluster. Pairwise is when the communication was established in between source and destination at that time. This particular key is used to establish a communication between source and destination. So this LEAP protocol, localized encryption and authentication protocol, will be worked on on the basis of key mechanism. So with the help of key, uh, the communication was established, the cluster was established, the data was transmitted in between the source and destination. And the other protocol is called sequential assignment routing. So in this, the nodes will be arranged in tree manner, which will create the multiple trees, where the particular root of each tree will be acted as the head, the cluster head, and from that root tree, each uh, node which is connected in one hook manner will be acted as a sink. So there are multiple sinks where there is a one hook connectivity, and likewise it will, when multiple sinks are formed, it will divide the tree into two trees so that one cluster head, that is one root, one sink will be formed in that particular root. So another protocol instance, so which will uh, use it to manage when there was a problem. What we discussed in communication, general communication, there is a fourth category. Source and destinations are ready, but they, because of the various reasons, the communication path may be terminated. So in that case, it will, this particular protocol will be used to minimize the damage. It will not completely overcome the damage, but it will minimize the damage which are occurred in that particular network. So when any node is malicious node, or simply we can say that any node becomes selfish node, if any node becomes the hacked node, or if any node becomes black node or gray node, in that case, this particular protocol will be used to bypass that particular malicious node in in that network. So in the transport layer also, this is also not required for wireless sensor network, but general phenomena we are discussing about the transport layer issues. So to make the reliable transmission, two protocols generally we are using in ad hoc network, in mobile networks as well as in sensor networks. But these protocols are not designed for especially for sensor networks. In general, these protocols are used to have the improve the reliability of the transport layer. So pump slow, fetch quickly. That is pump slow. It has to transmit the message in slow manner. It has to receive the information in faster manner. So whatever the node which is sending the information, that is source node, the source node has to transmit the information in slow manner. The receiver node, which will receive the information in faster manner. In that case, what is going to happen is there is some sort of disturbance between sender and receiver. So the performance of the receiver is going to be degraded because of the source is sending the information very slow manner. Let us assume that the source is sending the information at the rate of 10 kb per second. Let us assume that, and the receiver is receiving having the capacity to receive the information at 20 kb per second. Let us assume that. So in this case, per second the source is sending 10 kb, but the sender within half second only it is receiving this 10 kb. It has to wait for remaining 30 milliseconds to sense which are the two event to be occurred. So instead of wasting his time, what it will do is it will maintain one buffer. It will maintain one buffer. So in that buffer, first second 10 kb will be stored. In second 10 kb will be stored. Likewise, after that, after reaching the capacity of the destination node, it will transmit. The another protocol is called event to sync reliable transport. So in this particular event to sync, that means when any event is occurred in that particular network, that event, the occurred event has to be sent to the base station or the sync. So this particular sync is required to track the event when that particular event is going to be occurred. The sync has to track. But again, same. When it is outside the communication range, only the neighbors can sense that particular event. So in that case, the responsibility of the neighbor is to send the information or send that event to base station or the sink. So in this case, how many based on the number of packets routed from where the event occurred to the sink node, how many packets are going to be transmitted, and then once the initiating the transmission by the neighboring nodes, how many nodes are successfully transmitted, how many transmissions are performed successfully about that particular event to the sink node. If suppose if the based on the reliability, if suppose there is observed reliability, there is a required reliability, estimated reliability, required reliability. If the observed reliability is less than the required reliability, then this particular protocol uses to increase the frequency. So it will increase the frequency of sensing that particular event. Otherwise, if it is greater than, if it is not satisfied, then it will decrease the frequency to save the energy. So these are the various algorithms which in routing. Likewise, there are some other algorithms also there, but which are hybrid algorithms. Most of the researchers, what they will do is simply they will combine the features of multiple algorithms to form the hybrid one. So in routing, there is a scope for improving the research to enhance the research. So still there is a scope in energy related issues in wireless sensor network, especially in routing. So influence of mobility models in the link stability, and there is a future scope in huge scope in nanoscale communication, in body sensor networks. Body area network is different from body sensor networks. Web of things and integrating ad hoc sensor network deployed on-site web of things, and RPL routes scalability in case of moving nodes and discontinuous interferences. Routing for video YSNs, this is also the future research area. Routing for video YSNs, and there are some other researchers are also current researches are going on in various famous research laboratories. So we can find the current research going on in that corresponding research laboratories in worldwide. You can go and click on the link so that we can observe what are the current researches going on, what researches they completed. So this is all about. Thank you.